Introduction. Type 2 diabetes is a growing health concern. Early prediction, improved diagnosis, treatment and the quality of the life. Data mining, health analysis, patient record to the support division. For the technique in the prediction, the diabetic type 2 is the classification. Classification is predict a diagnosis. Use non-outcome to the train data. Number 2, predict if the patient have diabetic or non-diabetic based on the feature like BMI, feature, glucosa, and age. For the strength, it has a high accuracy and good for the early diagnosis. Number 2, easy to deploy in clinic. For the limitation, it need a labeling data and risk of the overfitting. For the division impact for the using a classification is early risk detection and support treatment division. Logistic regulation. A statistical model that estimates the probability of the binary outcome. Example, diabetic equal to 1 and non-diabetic equal to 0. So, how it works? It works like a compute a linear combination of features like glucosa, age, BMI. Apply the side mode function to squash output into the probability 0 and 1. For the advantage, it's simple and interpretable, fast to train, and good for baseline model. For the limitation, it assumes a linear relationship and less accurate if the data is complex and not linear. Next is a division table. For the division table, a tree like a model that split data based on division rule. Example, glucosa greater than 114 equal to what? So, how it works? It chooses a feature like the best split the data into diabetic and non-diabetic. It forms a yes or no question at each node. Leave a content final prediction. For the advantage, it's easy to understand and handle both numeric and category data, and work well with the missing value. For the limitation, it can overfit on the small data. For the limitation, it can overfit on small database, less table and small chunk in the data equal to different table. For the lastly is the random forest. For the random forest is an assembly method made up the many choice tree. How it works? So for the random forest, it trains a multiply division tree on the random subset on the data final prediction. Equal to the majority vote is the classification. For the range, for the strength, it reduces the overfitting common with the single division tree and robustness and accurate for the complex data. For the advantages, it's the high accuracy, work well with the large feature set, and automatically handle feature important. For the limitation of the random forest, it's the slower to train and the less interpretable than a single tree.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Anissa Aisyah binti Muhammad Muzaha and my matric number is 074662. So now let's start with pre-processing and feature selection. Pre-processing means preparing the raw data to be usable by machine learning models. It's like preparing ingredients before cooking. If something is spoiled or missing, the final result won't be good. There are a few key tasks in pre-processing, which is first, handling missing data. In a real-world diabetes dataset, some patients may have missing insulin readings or incomplete medical histories. Ignoring these missing values can lead to biased predictions. So, we apply methods like mean or median imputation to fill in the blanks, or sometimes we use more advanced technique like k-nearest neighbors imputation. Next, normalizing the data. Features like glucose and insulin levels can have large numerical range, while others like age or BMI may be much smaller. Without scaling, algorithms like KNN or SVM might give too much importance to larger values. Normalization brings all features to the same scale for fair treatment. Next, encoding categorical variables. If our dataset contains non-numeric values like gender or family history, we must convert them into numbers using techniques like one-hot encoding. Models cannot process text or labels unless we translate them into numerical form. And the last one is removing outliers. Sometimes you will find impossible values like a BMI of 200 or a glucose level of 0. These are either data entry mistakes or extreme cases that can confuse the model. Removing such outliers improves reliability of our predictions. In short, reprocessing cleans and structures the data so that the model can learn correctly and make accurate prediction. Now, let's talk about feature selection. Feature selection is the process of identifying which variables actually help in predicting type 2 diabetes. Not all features are useful. For example, in the PIMA Indians diabetes data, not all features are useful. For example, in the PIMA Indians diabetes dataset, features like glucose, BMI, insulin, and age are highly relevant. But something like the patient's ID number or hospital registration date adds no value to the prediction. Why is feature selection important? So the first one is it improves accuracy. By removing irrelevant or noisy features, the model focuses on what really matters. For diabetes, glucose level is a powerful predictor, but if we include too many unrelated features, we might confuse the model. And the next one is it reduces overfitting. A model with too many features may start memorizing the training data instead of learning patterns. That leads to poor performance on new patients. And the next one is it enhances interpretability. In healthcare, it's essential that doctors and medical professionals understand why the model makes certain predictions. A model using a few clear features like high glucose and high BMI can be explained more easily and trusted. There are many methods to select features like correlation analysis to find which features are strongly linked to diabetes outcomes. Next, recursive feature elimination to test which combination give the best accuracy. And the last one is using built-in feature importance from models like random forest. So to wrap up, pre-processing and feature selection are not optional. They are essential for building a useful and trustworthy model for predicting type 2 diabetes. Without pre-processing, our data would be messy and misleading. Without feature selection, our model could be overcomplicated, inaccurate, or even dangerous. These steps ensure the model is accurate by training on clean and relevant data, reliable by avoiding bias and overfitting, and the last one is understandable, so it can actually be used by healthcare professionals.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Farah Damia binti Magnesa and my metric number is 074502. Today I'll be talking about predicting type 2 diabetes using data mining techniques focused on building trust and ethical considerations. Okay, let's start with building trust. For healthcare providers to rely on model, they need to understand how it works and feel confident in its result. Okay, first, let's start with model explainability. When using predictive models in healthcare, it's very essential to make sure that the decision-making process is clear. This is why we use interpretable models like decision trees. These models allows healthcare providers or healthcare professionals to follow the logic behind the model's prediction, making it easier for them to trust and understand the result. This transparency is key in making the model a valuable tool for healthcare decision making. Next is performance transparency. We need to show how well the model works. This is done using important metrics like accuracy, sensitivity, specificity, and area under the curve AUC. This will help us see if the model is making correct predictions and handling all patients fairly. But it's not just about working in theory. Real-world testing ensures that the model works with actual patient data. By testing in a real setting, we can be sure the model will perform well in practice and make any necessary improvements. Next, to make things easier to understand, we use visual dashboards. This present a result in simple graph and charts, so doctors and nurses can easily see the prediction and make informed decision. Now, let's look at ethical consideration. It's important that model respect patient privacy and is used fairly. Okay, first, patient privacy is very essential. We need to protect patient data by following laws like Personal Data Protection Act (PDPA). So, information is safe and secure. Okay, next, we check for bias. If the data is biased, the model can give unfair result. We need to make sure the model treats all groups equally without favoring one over another. Okay, we also need to get informed consents from patients. This means they need to know how their data will be used and agree to it. This ensures their rights are respected. Okay, finally, accountability is crucial too. If the model makes an incorrect prediction, it's important to know who is responsible. Why the model helps healthcare professionals are still in charge of decision making. So, in the conclusion, when predicting type 2 diabetes using data mining techniques, we must focus on building trust with healthcare providers and patients by making sure the model is explainable, transparent, and ethical sound. By ensuring the model is accurate, fair, and respect patient privacy, we can create a tool that improves healthcare outcome for those living with type 2 diabetes. Thank you for listening.
In conclusion, to sum up, different data mining techniques like classification and clustering help us predict type 2 diabetes more accurately and support better decision making in healthcare. Next, pre-processing and feature selection are very important steps that improve the model's performance and make the results more accurate and understandable. And the last one is to build trust and ensure real-world use. We must focus on ethical practices, clear communication, and validating the model with stakeholders. With the right approach, data mining can play a key role in early detection and prevention of type 2 diabetes.